That's much better. Can I get a quick raise of hands from people who've been at Macquarie for a semester already? Okay, and students for whom this is the first semester? And students for whom this is the first lecture of the first semester, so prepare to be disappointed. This is Comp115. If you're here for psychology or Spanish, you're in the wrong room. Comp115 is the first unit in most of the information technology degrees, and also in some of other degrees such as information systems or data science or networking, etc. The description of the unit is self-explanatory. It's Introduction to Computer Programming. So when we hear about computer programming, if you visualize computer programming, just like close your eyes, visualize a computer programmer, and most of us will inevitably see a nerdy-looking person sitting in front of a computer. Is that right? While in reality, it's typically a nerdy-looking person without a computer. So it's almost an oxymoron in the sense that computer programming doesn't need a computer. Almost all fantastic programmers, almost everyone who's a genius in the field and has written most of the software that we use on a day-to-day basis, including Linux, Android, Mac OS, Windows, DOS, Bash, etc., they're all mostly electrical engineers. That's amazing. The reason I'm saying this the first thing in the lecture is because you will be doing a few units in programming over your degree. You'll be doing 115, you'll be doing 125, 225, 229, 249, 202, 333, etc. But if you approach it from the perspective of, okay, I'm going to try writing a program, and if it doesn't work, I'm just going to change stuff and hope it works. That's an approach a lot of students and even professional programmers sometimes use, which is definitely not recommended. The correct approach towards computer programming is to understand the basics, to understand why things are happening, the way they are happening, and there's always a reason why the program is behaving in a way it's behaving. So instead of writing a program, whenever you're given an assignment, whenever you have an exam, whenever you have a prac exam, so my main unit is Comp125. I also lecture 115, but once you pass 115, then you come to Comp125, which is Java programming. And that's my bread and butter. In that unit, students who make an effort of understanding why things are happening will always do better than those who don't. Is that okay? So that's the first thing I wanted to say in the lecture, because usually it's the first thing that the students remember and then they fall asleep. Now, that said, if you have any problem during the semester, my email address is in the unit guide. The unit guide is there on the page. It hasn't been updated. Now, it's not my job to update the unit guide, but I'll do that. Comp115, semester 2 day. This is the semester 2 offering. Now, thankfully, there are no changes to the offering, so we don't have to worry too much about that. Turn it on, unit guide, edit. And that's the right unit guides. Save changes and go back. Probably a good point in terms of hierarchy as well. Any unit that you'll do will have a convener. Convener is the big boss. Convener decides the assessments. Convener decides the exams. Convener decides the lecturers. And everything else is the job of the convener. So Matt Roberts is a convener. When you saw the timetable, you must have seen Monday 10 to 12, Matthew, Damien, Roberts, right? And then you saw me, and then you were confused. My name's Gaurav Gupta. I'm going to be lecturing the first 6 weeks of this unit. And then Matt and Kim will take over. So my email address is there. Almost every lecturer, almost every staff member in Macquarie, their email address is their first name dot last name at mq.edu.au. Unless you get Jack Smith or Jennifer Lee, something like that. Then it's Jennifer.Lee 8, 9, 10, etc. So common names are numberized. But anyways, my email address is gaurav.gupta. Any help you need regarding 115, please feel free to contact me. In terms of support, next point. How many of you have done programming before? Okay. You can see that. Can you raise your hands loud and big? If everyone looks around the room, you can see that 20% students have done programming. 80% students haven't done programming. Those 80% students who haven't done programming, how many of you are scared that these guys have done programming and they'll be much better than you? Who's intimidated? 1, 2, 3. Come on. Come on. 4, 5, 6. Okay. So 6 people are telling the truth, at least. It's always very scary coming to university, doing things that you haven't done, but others have done before. And the other students who have done computer programming, some of them will be modest and keep their knowledge to themselves. Some of them won't be so modest. So they'll make it known that they've done programming before. Okay? My advice is to ignore anyone who's done programming before. Yes, they've got a head start. They've got a head start, but that head start won't last for a very long time. I give it about 2 semesters, typically, till you catch up. So within 2 semesters, you will reach the level that they are at. So when you enter second year, there's no gap in knowledge between you and any other student. The other thing is that if you're intimidated, know that all our assessments, all our content, all our delivery is based on the assumption that no one has programmed before, which actually means that lectures and tutorials will kind of get boring for those 20% students. But what do we do to address that? Let's see. I used to lecture Comp115 in semester 3. So it was a block program. It was an intensive offering. And some of my students and I collectively, so these are students just like you guys, and these are students who have a significant amount of programming experience. We developed a set of practice programs for the benefit of everyone in the class. So as and when we discuss these topics, topic 1, topic 2, topic 3, topic 4, 5, etc., we start asking students to write programs that achieve certain outputs. So, for example, if you've just started programming, that's a good place to start, writing the most basic programs. And once you've written that program, moving to the next program, where you add lack of opacity or translucent behavior. Then you can add some more shapes and some more complexity. By the time you reach the end of a package, this is the last program, by the time you reach the end of the package, these are the kind of programs, they are a bit more challenging. But there's a very incremental progression from one program to the other program. So you cannot expect to write this program straight away. But it will help you immensely to do all the previous programs to write a given program. Does that make sense? So it's incremental in nature. Okay. Now, what I was saying is for advanced students, right? So students who've done some sort of programming, we always have, I would advise you to go back to front. So if you have done a lot of programming, start from 12 and go to 11, 10, 9, etc. So start from 12, and it's a program where it's inspired by Flickr logo. So when a Flickr image is loading, there are 2 red and blue circles that are going round and round and round. But the front view looks like it's linear. But once the blue circle's in front and the second time the red circle's in front. And then move on to the next program. This is not 115, what I'm going to show you just now. What I'm going to show you now is 125, Comp115. In Comp125, we're going to give you these Java practice packages that contains questions on arrays. And within arrays, there are 4 stages. Stage 1 is very basic programs. Stage 2 is your typical passing grade programs. Stage 3 is between credit and distinctions. And stage 4 is just me being grumpy and nasty. And they're really challenging programs for anyone who has started programming with us. But what I mean to say is, if you have programming experience, then you should solve these tasks. For example, take a look at this one. Get longest descending sequence. So you have a collection of numbers, and you're trying to find out what's the longest sequence which is in descending order. So let's take a look. 10. By itself, 10 is in descending order. If you're your parents' only child, you're their favorite. So single item is already sorted always. 10 and 70, when you consider 2 items, are they in descending order? 10 followed by 70? No. So that's not in descending order. So 70, 50? 70, 50, 20? 70, 50, 20, 10? So that's my longest sequence so far. 70, 50, 20, 10, 50? No. So the chain breaks. So you start again. 50, 50? Yes. 50, 50, 80? No. So your longest sequence was 70, 50, 20, 10. So what we'll do is, we'll release these programs to students, and students who find the normal stuff too easy can do all these things. Is that okay? If you want additional resources, if you need something more stimulating, please email me, and I've got a bunch of resources that I can redirect you to. Off the top of my head, ACM programming competition. So you might want to note this down. ACM programming competition. So anyone who's got a significant experience and wants to do advanced things, go here, and I can guarantee that you will be stimulated and frustrated. Next, support sessions. In Comp115, we offer what's called PAL sessions. PAL is peer-assisted learning. What we do is we identify students who have performed exceptionally well and who have the kind of personality and the kind of aptitude to help others. So it's very much possible that somebody gets 100, but they're not a good communicator. So we identify students who are academically brilliant and who can communicate the point across to other students. We recruit them, and they offer support sessions to current students. This semester, we've got 2 students, Radid Ahmed, is that right? And Jack Barnes. These guys have done 115 before. They've done it really well, and they're more than happy to help students for a price. So Radid, you want to introduce yourself? All yours. I'll pop up the timetable while you're talking.
Hi, my name is Radid, and I am one of the PAL facilitators for Comp115. So what is PAL? Basically, PAL is a 1-hour study session that's going to start from week 3 and continue all the way up to week 13. In each of these sessions, we will be handing out worksheets that have questions with different levels of difficulty, and you'll be working together in groups to solve these problems. We, the PAL facilitators, will be there to help answer your questions and any confusions you might have about the topics that we'll be covering. And we'll also help improve your study skills and provide you with tips and tricks that have helped us do well in the unit and should help you as well. I think the most important thing I want to emphasize about PAL sessions are that it's for everyone. So whether you are someone who's just trying to pass the unit or a distinction level student trying to get that high distinction, if you put in the time and attend each of the sessions regularly, PAL can help lift up your grades and help you reach that next level. And yeah, and lastly, PAL is completely free and voluntary. So really, if you have the time, just come on over, have a look at it. It can definitely help you out. And bring your laptops if you have any, though it's not necessary. It's mostly written work. But yeah, that's all I want to talk about PAL.
Thank you very much, Radid. So you want to stay for the whole 2 hours? Yeah. I'm joking. Okay. PAL sessions, you don't have to actually note down the timetable for PAL sessions because PAL sessions are a form. Radid, it's okay, man. Do you want to? You don't have anything better to do? Be my guest? Okay. So if I check Comp115 and this week, it won't come up because PAL sessions are not scheduled for week 1 and 2. But if you select session 2, Comp115, and all weekdays, view the timetable, and I made a mistake. I should have gone to the week view. Comp115, session 2, all weekdays, view timetable. That's what it looks like. Radid, why does it say Monday? I thought it's Thursday.
So yeah, we changed it to Monday. So we have
sorry, my mistake. Okay, so PAL sessions are on Monday. Okay, so please note this website as well, timetables.mq.edu.au. It's a really useful website to know where your classes are, etc. Maybe I should write it down in a bit bigger fonts. The name of the URL is timetables.mq.edu.au. That's one URL that you might want to keep a note of. The second URL is units.mq.edu.au. Units.mq.edu.au will then redirect you to unit guides. And here, you can take a look at whatever unit that you are doing right now, which, for example, is Comp115. Search for this. These are the offerings in 2019, and we're in semester 2. The most important sections of a unit guide are, obviously, assessment tasks. So make yourself familiar with what the assessments are and what these assessments mean. In 115, you have module exams, which basically mean that we assess every topic, and we assess it multiple times. So you have more than one chance to pass a given module. There are 6 modules. There are 6 modules in this unit. One is Foundations of Programming, where we deal with study skills, academic integrity, things like that. Variables and conditions, loops, functions, and compound data. All but the first and last modules are mandatory to pass. So it's okay if you don't pass module 1 and or module 6, as long as you pass each of modules 2, 3, 4, and 5, and you get 50 marks overall, and you pass enough sufficient in-class exercises defined here. Students must demonstrate satisfactory performance on the in-class exercises to pass, is defined as getting 40% or more in each of 6 or more of the 9 classes. So there are 9 in-class exercises. In 6 of those, at least, you need to get 40% or more each. Is that okay? So that's a faculty-enforced rule. That's not a rule that the convener has enforced. So 3 rules to passing 115. The modules that are mandatory, you'll get 3 attempts at them, which is quite a lot, right? So you get the first attempt. You can just wing it if you want, or you can make a serious attempt, or something in between, okay? Whatever your strategy is, you can use that. The benefit of every strategy has its own benefit, okay? I'll talk about the idealistic situation where you make a sincere attempt the first time. It means take a look at the unit schedule. The module exams, Foundations of Programming, Variables and Conditions, and Loops. And then Variables and Conditions and Loops again. So my point is that you can attempt one. Okay, don't take this as an advice, okay? This is a hypothetical situation. So it's possible that a student does one module sincerely and makes every effort to get a really good mark in that, but does a trial attempt at the second one. So you might get 80 on the variables and 20 on the loops, which means that you don't have to attempt the variables again because you got 80. If you don't want to, you can skip it, and you can do loops sincerely. So you can focus your efforts on one module. But whatever strategy you want to use, you can do that. Any questions? Yes?
Sorry, I'm still not aware where to find the resource material to read.
Okay. Where do you find the resources? Where's the lecture material? So you can see anything that is grayed out is hidden from the students. But if you take a look at the table right at the top of 115, you can see these are all hyperlinks. So that's the teaching material, okay? So in today's class, our objective in the 3 hours, today is your first lecture, tomorrow 4 to 5 p.m. is your second lecture. Is that correct? Okay. So the objective for week 1 is to transition to processing, to have a transition to processing discussion, academic integrity module introduction, which you're supposed to do at home, and introduce some study skills. So you can see that's your teaching material that is required for week 1. But what I like to do is, I like to do a little bit more than what's on the timetable. So I'm going to go a little bit into primitive operations as well. But that doesn't mean that next week I'll skip it. So next week I'm going to start again with primitive operations. So there's kind of an overlap between week 1 and week 2 lecture. So thank you for asking that question. I can understand it's not very clear because it's not underlined. But yeah, those are hyperlinks. Any other question? Yes?
Let's say a student gets 80% on BNC test.
Yes?
Gets 20% on the second one.
So if you get 80 on the first one and 20 on the second one, then the best mark counts. So you can have multiple attempts and the best mark counts, and that's how the module exams work in 115 and also in most of the other units. Any other question? Yes? That's the sentence you're referring to. Students may only attend module exams they are enrolled in. So this phrase, yes, it's misleading. Again, I'm a lecturer. I deliver the content. I don't write the unit guide. But 1 to 5 unit guide, I write. So it's my problem. The phrasing, I think, should have been, students may only attend the practical classes they are enrolled in. So on each student, you enroll into a lecture, you enroll into practical classes. So if you're enrolled in a Tuesday 4 p.m. class, then you have to go to Tuesday 4 p.m. class. You can't go to another class. So this phrase, this term, module exams, should be practical classes or practical sessions. Any other question? Yes? All the enrollments are managed through each student. That's right. So in order to minimize the frustration that you might have to suffer and Matt might have to suffer, please don't email Matt requesting, I've got a work commitment on Tuesday night, can I do the module exam on Wednesday? Okay? A, you will not get a reply from him, and B, if you get a reply from him, it won't be a very sympathetic one. By enrolling into a unit, you are committing over the semester that you will attend the lecture and certain practical sessions, and we expect you to fulfill that commitment. It's up to you to rotate other aspects of your life around this commitment. I know it sounds very brutal, but we all do that. I do that myself. If I have a lecture Monday 10 to 12, I have to do the Monday lecture 10 to 12. If I'm given a lecture Tuesday 11 to 1, as much as I would like to play my lunchtime soccer, I have to turn up to Tuesday 11 to 1, right? So that's what it's about. That said, you can always come and have a chat with us, explain your situation. Some scenarios require convener interference. I had such cases last semester, for example. There was a student who had family medical emergency. So rather than going through the whole red tape of making an application through ask.mq.edu.au, I told the student, don't worry about it. Attend to the medical emergency as and when you need, and as and when you're ready, you can come and do your prac exams in my office. So we are sympathetic where sympathy or empathy is warranted. But if you say that I've got a project deadline at work, so I can't come to my prac session, that's not a reasonable excuse. I'm not kidding here. 2 semesters ago, I had a student who said, I booked a holiday to Hawaii. So can I do, and he didn't even say, can I do the prac exam earlier? I would like to do the prac exam earlier. I'm not going to entertain such requests. So I offered the student, look, I can do one thing for you. I can go to Hawaii for you, and you can do the prac exam in week 7, okay? So be reasonable in your requests, that's all. So that answers your question. Anything else? Yes? Are the practical sessions on week 1? At this point of time, I might redirect your attention to this thing called Discord. I myself got on it last semester. I'm pretending to be young, but I still don't get it. But students love it, so there you go. Discord is like, I don't know what it is. I just use it as a chat thing. And in Uni General, yes, the first word you see is the F word, fine. Let's search. So Discord is your unofficial student support channel, basically. So almost all discussions that happen about computing units are on Discord. So you can download Discord. It's a phone app as well. So here I've put a link and said, click on when practical tutorial workshops will start. So if you click that link, and take a look at when will classes start in session 2. These are the lists. So that answers your question. Is that okay? I said that Discord is the unofficial computing support channel, community. Let me show you the official community now. Anyone knows about it? The official computing community, one person. So on iLearn, there is a community units section. You'll have that on your iLearn as well. If you click that, there's computing student community. It's a bigger ghost town than Google+. And most of you don't get that reference, which shows how big a ghost town Google+ was. Forums, discussion forums. Wow. I'm also the student liaison officer, which basically means I try to increase student staff engagement in computing. So we organize events and things like that. It is very slow, mostly because of budget constraints. Now, what I tried to do is I'm trying to rationalize to the department that we should discontinue this community student thing and then officially adopt Discord as the proper channel, because for any unit that you see, Comp115, the discussions are unending. Students are much, and a lot of learning happens here as well. So there's a student who's asked, can someone help me trace this function? And there were at least 5, 6 other students who jumped in to help. So that's where the real learning happens. Of course, a lot of other things happen, which I ignore, but a lot of learning happens as well. Yes? See, that's where I show that I'm actually very old. I don't know what a server code is. No, but what, let me, so this is where I can go to home and Jordan. Let's see, he should reply. He's usually waiting on his phone to reply. So what I did is, to make my point to the faculty, I recently had, and by the way, all of you are enrolled in that unit, so you all have access to that unit. I made an announcement, sorry, not an announcement, I posted on the discussion forum gauging the number of students who read the discussion forum. And please use yep or no on this link. I selected no because I never do. Bear in mind, this unit, this community forum platform has over 1,500 enrolled students. 1,500. And there are 7 responses. And that proves my point, basically. So in the next week or so, I'm going to take you to the faculty, and what I want to try and do is adopt Discord so it becomes a formal process without staff interference, obviously. We should get the server code in about 20 odd minutes, but yes. So that answers your question. Next question, please. Yes.
Not exactly a question, but server and invite people using the server. Okay, the private server, you can't invite people.
I'm assuming private server is something. Okay, fair enough. But yes, the other thing. Max. Macquarie Association for Computing Students, bracket Max, is the Facebook group. It's got 820 members. It's not as active as the Discord group. The Discord group is like off the charts. I open that thing in the morning and there are like 120 messages or something like that. It's also very effective because I can ask students things like this. Is anyone who's done 1 to 5 interested in helping me code a bunch of methods? And then I can get a bunch of replies for people who are willing to help. So it works really well, constructively speaking. Okay, Jordan has already messaged. That's the link. Let me copy this link. Can you join the server through this URL? Yep. Okay, so you can note this URL and join. So, okay, get back to the message. Is that it? Oh, so apparently people already joined. Anyways, Discord is fantastic if you use it properly. Of course, there's a lot of random chat happening there as well, which might actually be of interest to you. So use it as you wish. Is that okay? The link expired. What's that?
I think it's an invite for only one person. After each person joins, so that link is expired.
This one. Oh, sorry. There you go. Next question while we do this thing. Yes? No? Just a yawn? That's fine. Yes. Okay. So again, as I said earlier, this in-class exercises is a rule that has been enforced by the university, by the faculty. So the faculty requires us to have participation marks in 100 level units. It's mostly because 100 level students come fresh out of high school and they require some sort of guidance. Otherwise, they will go astray. So in that sense, it says there are 9 in-class exercises, right? And you need to get 6 marks out of the 9, 6 satisfactory marks. Then, if we take a look at the unit schedule, you can see the in-class exercises are in week 1, 2, 3, 4, 6, 7, 9, and 11. Now, let's say you have done programming before, and it's not worth your time going to the workshops. In that case, what you can try and, of course, do is knock off these 6 marks that are required in weeks 1, 2, 3, 4, 6, and 7. Correct? So by week 7, you'll have the minimum required marks. Yeah? And then you have to attend the weeks in which the module exams are provided. But again, you have to decide what your situation is. So if I had done programming before, I would not do foundations in week 5, and I would just do it in the exam period. But I have to be confident in my ability, right? So I can do everything in the exam period, which means that I don't have to attend week 5, week 8, week 9, week 11, if I had that sort of confidence or overconfidence. But for most of the students, I highly recommend that you actually try and come to attend as many module exams as you can during the semester and not leave it to the end. All these in-class tests are during the practical session. So that's a good point. What I'll do is I'm going to make that change here. Oh, lectures are not mandatory. No, you can just walk out right now. I mean, seriously, right? Why do you want to come to the lectures? Because it offers some value, right? And if my lecture is not offering any value, you don't have to come to my lecture, especially waking up 7 o'clock on a Monday morning, commuting for an hour, 2 hours sometimes. Then definitely you need to see value in every activity that you are investing time in. Okay, so in-class marks in practical session. Let's add that. So there you go. So now it's clear that these classes are in practical, these exercises are in practical sessions. Next question. Yes? So it's a very, very flexible schedule. I can do all these 3 things today, and then tomorrow I can just talk about some exercises that expand on that topic. But typically speaking, I will cover about 80% content today and 20% content for a given week in Tuesday lecture. The reason being, Tuesday lecture is a 1-hour lecture. So fewer students attend that, which means I want to maximize what we achieve in the Monday lecture, where most of the students who are going to come actually come. The second thing is, Tuesday lecture is a 1-hour lecture. By the time I get started, it's already 10 odd minutes past 4 o'clock, and we are supposed to finish 5 minutes before the lecture finish time, so it only gives me 45 minutes. And really, what can I realistically achieve in terms of teaching a new content in 45 minutes? Nothing. So mostly what I do is, I introduce new content on Mondays, in the first lecture, and then I have a discussion with some exercises, some programs, some demonstrations on the second lecture, in the second lecture. Next question, please. Yes. As I said, if you're coming only on Monday to the university, it will cover 80% of the content, typically speaking. But both Monday lecture and Tuesday lecture are recorded. So you can watch the Tuesday lecture on Echo, sorry, that was the old terminology. You'll see on the right-hand side, there is active learning platform. Radit, are you officially required to sit on the lectures? Yes. Okay, let me rephrase that question. Are you getting paid for it?
Yes.
You are? Okay. So Radit, in that case, what I'm going to request you to do is keep the active learning platform open on your phone or computer, because students who are watching this lecture at home, because it's being live streamed. So somebody who's living in Hurstville, for example, might not find the enthusiasm to come to Macquarie on a Monday morning, and they can post questions over here. So Radit, if you are, so I was waiting for Matt to do it, but I'll give you access today. Anything else? So does that answer your question? Next one. But that said, try and come to the lectures if it offers you value, and especially if you are not, if you need some support. If you're doing fantastically in everything, then I don't really care whether you come to the lecture or not. But it's the students who are not doing really well and not coming to the lecture, that becomes a problem. Okay? So see how you go. Next question. Yes? So in the practicals, what's typically going to happen is we're going to have a series of exercises and tasks and questions. Each practical demonstrator has complete freedom on how they want to cover the class. So what's going to happen is, I think that's a very practical point in this sense. In the first 2-3 weeks, what I advise you to do is go to the practical class, see if you like the tutor's teaching style. Some tutors are very methodical. They'll go through questions one by one. Some tutors are creative, they're very innovative. They'll spend the first 10-15 minutes somehow identifying what are the gaps in knowledge of most students, and then they'll adjust their session accordingly. So spend the first 2-3 weeks deciding which tutor you actually like. Obviously, you can only go to your own session officially, right? But you can talk to your friends and say, how does your tutor handle things, and is your tutor good at getting the point across, things like that. So if I go to module 1, which is now visible, you can see FP Lab 1. So on Island, wherever it says labs, that's the content that will be covered in the practical classes. If I take a look at FP Lab, you can see it's a series of questions. And the series of questions tries to identify whether you understand the content properly or not. And typically speaking, the last question is the end game. So whatever you do in questions 1 through 5, we are trying to put together in the last question here. And then you guys can do this. And that's it. I'll show you Comp115 practicals as well. So Comp115 practicals are all put on a website called GitHub. We are using it as a website, but it's more than that. But students don't need to know that. You can see week 1 introduction. This is Comp115, not 115, okay? You don't have to do this right now. So there's introduction, and I've got an outline. This is my suggestion, how tutors can spend time. And at the end of it, we always have students who are required to attend the practical classes because of that participation mark. So in order to make worth their while, worth their time, we include advanced questions. And I have sufficient confidence that these sort of questions will take even proficient students enough time that they'll be entertained during the class. Is that okay? So go through 115. 115 is very basic programming, but when you come to 125, we're going to intellectually challenge you even more. Okay, but all in good time. So that's your question. All good? Next one. Okay. So, any other questions? Yes. I can't comment right now. In the past, we used to use them as in-class exercises, but what it means is that it adds a lot of workload on the tutor because they have to go around and check everyone's answer. So this semester, what we're going to do is we are thinking about having an island quiz as the in-class exercise. So in the last 10 to 15 minutes, you'll do the quiz gets auto-marked. So if we can assess whether a student satisfies the learning outcomes, then we don't want to waste your time and we don't want to waste the tutor's time either. So most likely it will be island quizzes. Is that okay? Sweet. So if that's all good, we can now move to our core lecture contents. I'm going to go through academic integrity module and study skills first, and then I'm going to move to transition to processing. Macquarie, and Macquarie, like every other organization, has a code of conduct. In universities, it's called academic integrity. Academic integrity applies not only to students, but also to staff members, also to PhD students, also to professional staff. So everyone is bound by academic integrity. From the point of view of students, there are several aspects, but what I'm going to focus on is A, respect, and B, honesty, because those are the most relevant ones, okay? In terms of respect, you guys are really well behaved, which is fantastic, but not all my lectures are like that. Sometimes half an hour into the lecture, we have students just casually coming to the lecture, but not through the side. They will make a point to go around everyone and then sit right in the middle, disturbing 10 other students. So little things like that. So please be mindful that this is a learning environment, and the way you behave towards your peers and towards your staff, the way I behave towards students, there needs to be some sort of consideration for others. The second thing is, in lectures, it's not as prominent, but in practical classes, it happens even more. There are practical classes where 20 students are being taught by one tutor. Not all tutors might be perfect. In fact, very, very few tutors would be completely satisfactory for you. So every tutor will have some flaws, but they also have their strengths. If there is a problem, discuss that problem in a respectable manner. Please do not disrupt the class. Please do not make it a point to demonstrate your displeasure as being required to be in the class and things like that. If you have significant experience and you think that it's not offering you any value, email me. And then when you email me, I can redirect you to the resources that you can do in order to get that part, in order to keep you busy during the practical class. Unfortunately, the decision to waive that requirement is not up to me. So I can't just waive your requirement. Okay, I know you know everything, but I can just waive the participation requirement. Okay, that's something that I cannot do, because then I'll get into trouble, which I don't like. In terms of honesty, very, very basic thing. I should turn off my phone as well. In terms of honesty, the very common thing that applies is assignments. And in assignments, collaborative work, if it's an individual assignment, collaborative work is obviously not allowed. The most typical scenario is, what's your name? Yes? Mimi? Nimi. Nimi. The most, and what's your name? Jenny. The most common scenario is Nimi, Jenny might be friends. Maybe Jenny finishes the assignment. Nimi says, I'm struggling with a component, and you just casually just look over Jenny's code. Nothing else. You're just looking over her code. She says that, look, I solved it like this. You look over her code. But the problem is, as soon as you look over somebody's code, psychologically speaking, your subsequent problem solving will be determined by that. And the way you write your program subconsciously, not explicitly, not deliberately, not intentionally, but even subconsciously, the code that you write will have very close similarity to your friend's code. So one of the things I tell my students is, when you're doing individual assignments, talk as much as you want between each other. You can talk about, I was trying to make the ball bounce, but it kept going below the ground, and the way the other person can respond is that I had the same problem, but by adding a display statement to trace the y coordinate, I know most of it sounds gibberish, but I controlled the y coordinate by having a debugger statement, and that showed me my mistake. So keep things abstract. The main reason, and then of course there are blatant form of plagiarism as well, where two students submit the same assignment. Last semester, I had twin brothers in my class who submitted the same assignment. You don't have to do everything together. Now, the main problem that's going to happen is, once this sort of thing happens, once I identify or flag two students for plagiarism, I have no choice as a lecturer, because it's my duty in terms of academic integrity, to report you to the faculty disciplinary committee. Most of the times the penalties are not as severe as I would like them to be, but they are a massive pain in the backside. Because semester 1 academic integrity cases are still being processed right now, which means if a student was referred for plagiarism in Comp115, they cannot enroll in 125 still, which means they cannot select classes, which means that they'll get a Friday 7 p.m. class probably, or a Monday 9 a.m. class. Okay? So things like that will adversely affect your progression. The point being, individual assignments, make sure that you do them honestly. Do your best, because they are to assess your progression. Do your best, even if you get 50 out of 100, 60 out of 100, 70 out of 100, that's an honest mark, which is better than 90 or 100 by colluding with each other. And we have various ways of identifying collusion. We don't have to have the same marker mark two assignments to detect that two students plagiarized. Because this is software, right? And software collision detection is extremely easy. So there are lots of plagiarism detection tools that we use. We just throw in all your submissions to a server, and the server replies that these are the students who have colluded. with certain possibility. So I get things like this. In lines 202 to 330 and 182 to 302, there were these similarities. Now the students, what they've tried to do is, they've replaced the variable new value, new underscore value, by new value without an underscore. Brilliant. But the thing is, the plagiarism detection tool doesn't see variable names. It actually renames the variable lexicographically. So it just replaces them by ABCD and other optimization tools. But you can see these two codes, except the comments, which are in 2 slashes, they are identical. So this is the sort of evidence then I have to collect. So I'm already grumpy by that stage because it increases my paperwork. And then I refer it to the committee, and the committee then takes its own sweet time, which is the worst. Because between then and the decision, which takes 2 to 3 months, you cannot enroll in other units or subsequent units. So that's the main problem. So avoid that and make sure your assignments are your own work. Anyways, please note that there is an academic integrity module. There are 5 aspects of that. So please complete this module. You're supposed to do it yourself in your own time. Okay? But that's a mandatory module for all 100 level incoming students. Questions about academic integrity? Anything? Yes?
It's not about academic integrity, but does the uni have its own plagiarism software? Or is it somewhere?
We may or may not have it. Okay? Anything else? Yes? I love the fact that you're already trying to circumvent the system. Yes? Yes. So all the modules start from scratch. So this is a fresh attempt. So if you have passed some modules in the previous semester, it doesn't count anymore. Oh, no. Oh, sorry. If you have completed academic integrity module last semester, then you don't have to do it again. Yes? I agree. So what's your name? Oscar. So what Oscar is saying is that sometimes you might have programs which are very, very simple. So for example, if I have to check if a number, if I have to compute the square of a number. So let's say I have a number 5. Don't worry what this is right now. You can kind of make sense what it is. But if I have a number and I need to check what is the square of that number, then I'm going to do n times n, right? Now, very few students will do it differently, if any. So I agree, but plagiarism only applies to non-trivial codes. Okay? So if there is a trivial piece of code which is done in an obvious fashion, then of course we don't identify the similarity in that. And that's why writing good assignments is up to us. So it's our responsibility to write assignments which have multiple ways of solving it. But false positives in that sense are not your problem. So if your code is accidentally similar to somebody else's code, then I go through all of this, if I can type correctly ever. Then I go through all of this. So when the report comes out, then I actually have to inspect this and see, okay, what's the probability that those two are accidentally like that? Okay? So a lot of things I ignore because I can see that it's only fair that 2 students might have reached the same approach without colluding. So yes, you don't have to worry about false positives. Yes?
Sorry, there's a lot to take in, so can I have some key points that I really need to take away from the lecture? Like some very key points, so I can summarize the lecture.
No. I mean, that's the whole point, right? Like right now, what I'm doing is I'm addressing all the concerns that you have about the unit. So there's no, I can't give you a 2-minute summary where these are the things. But what you can do is you can watch the lecture again, and when a student asks a question, the response to that question is your key point. But I understand that I'm not to the point, so it's up to you to summarize my response. Next thing, yes? You can watch it over and over again if you have the stamina. I don't believe, at the risk of getting fired from the university, I don't really like this live streaming because it's a lot of, it takes a lot of stamina to watch a 2-hour lecture. Hell, even a 2-hour Game of Thrones episode is hard to watch. But watching a 2-hour lecture where the lecturer is monotonous, we are talking about things that you're not interested in, is very hard. Slowly we are moving away from that. And we are moving to, this is Comp115. So we're moving to short videos, which are 5 minutes to 10 minutes. These videos can be embedded on a web service, and you can watch that on the bus, on the train. So my aim is to make that 1-hour commute that a lot of you guys have worthwhile. So instead of, so this is a 1.5-minute video which summarizes what might be a 10-minute discussion. So I understand what you're trying to say, but we are limited by how much time we have to develop those resources. But to answer your question, and this is the key point, ready? You can watch live streaming multiple times. Any other question about academic integrity? If you're not sure, ask your lecturer. That's the key point. Next one. Okay, I'll stop picking on you. Spaced repetition, study skills. Study skills are some advices that we have. Obviously, I've been giving some informal advice already, but spaced repetition is the best strategy, in our opinion, to learn at least computing units effectively. It's a really simple graph. What this graph indicates is if you come to the lecture and you pay attention in the lecture, and for how many days will you retain that information? So this is all research that has been done in cognitive science with empirical results. So it's not just our hypothesis. This is proven research. If you study something once, whether on your own or in a lecture, you'll start forgetting it exponentially. And by day 6, you'll hardly remember anything. But after the first lecture, if you revise the content on your own, and you don't have to spend 2 hours revising a 2-hour lecture, you only have to spend half an hour. And that's not much. That's very reasonable to ask you guys to spend half an hour. If you spend half an hour after a day, then the rate of decay, as we call it, information decay, is more gradual. So you'll remember more content at the end of day 6. And obviously, if you revise it a couple more times, then the information retention is very solid. That said, I don't need you to watch the live stream again and again. That's a very inefficient way. The way you do that is after the lecture, you should go through the lecture material one more time, assuming you have downloaded and installed processing, copy and paste the following code. What is the end result? And here's a description. Now, based on that description, think about, what if I change some things? Can you guys see this at the back? Can you guys read this at the back? Good. Okay. So when I run this program, I can see a cross. Now, which statement is responsible for which line? I don't know. And I want to check how do you check that? You check that by getting rid of one of the statements. So you can now see that it was the first statement that is in charge of the line that goes from top left to bottom right. And therefore, the second statement must be the statement that is in charge of the line that goes from top right to bottom left. And that inference, that deduction capability is what's going to improve your understanding. Once you have that understanding, you can now say, hey, I'm going to change some things, and I'm going to make it, let's see if I make it 2030 or 2040, what happens? And you can see that it changes, one of the point changes, which tells you that the coordinate of this point over here is 2040, while the coordinate of the top left point is 0, 0, because previously it was 0, 0, right? So it's all experiment-based learning. You change things, you see what's happening, you try and deduce why this happened. You try to correlate this. And that's a really nice way of learning basic programming. And there are different strategies for advanced programming, then we'll talk about that later. So once you've done that, I can also say, instead of, let's just focus on one of them. Instead of width, height, it's width minus 50, height minus 50. If I run this, the bottom right point moves to the middle of the screen, which means that 50 displacement is half the width and half the height, which means the entire width and the entire height must be 100 each. So there you go, just by a little experiment, now you know that the default processing output is a 100 by 100 display window. Yeah, you can change that, but we'll talk about that later. So that's how you study. We have some tasks, and do these tasks. Similarly, these ones, 1 plus 1 is, we are asking you to compute things or arithmetic operations in terms of programming. The computer performs math differently from how we perform maths. Is that okay? When we represent things in one way, it means something different to a computer than when we represent it slightly in a different way. For example, in this case, I can write the number 12 as 12, or I can write the number 12 as 12.0. But for the computer, they are two very different things. While 12 indicates that it's a whole number, 12.0 indicates that this number can be split up into decimal components, okay? Which means when I tell the computer, divide 12 into groups of 5, this is the meaning of 12 divided by 5, 12/5. This means, and that's a really bad example, I'll tell you why later. When I say, let's take a new number, 17 divided by 5. See, this is the sort of thinking I have to do as a lecturer. I'm saying 12 by 5 is a bad example. 17 by 5 is a good example. I'll ask you guys in a little while why am I saying that. Okay, so I'm going to take 17 by 5. What I'm trying to do is I'm trying to divide 17, which is a whole number, into groups of 5. So think of 17 students, and I'm trying to divide them into groups of 5 for assignments or whatever, for prac class, anything. How many groups can I create? That's right. So it means that 17 by 5 is 3. But there are 2 sad students because they didn't find a group, right? So we call this the mod operator. Mod is the remainder is 2. So 17 divided by 5 is operating in what we call whole number domain or integer domain. Is that okay? But the same thing, when I say 17.0 divided by 5, it means that I have something that can be split. I can break it and give it partially. So if I have 17 muffins, I don't know, I couldn't come up with a better example. I have 17 muffins, I've got 5 kids. I don't have 5 kids, but let's say I've got 5 kids. Each one of them can get 3.4 muffins and be all sugared up. But the answer is 3.4, and that's it. So if you spend time understanding the fundamentals, understanding more complex concepts becomes infinitely easier. And vice versa, if you skip fundamentals, understanding more complex things in 1 to 5 will become incredibly challenging. Take a look here. Rebrand, Comp115 practicals. This is one of the things that I assess again in Comp115. That's the first thing I do. Again, I've got a poor example here. I should fix that. What's the difference between int result equals 12 by 5 versus float result equals 12 by 5 versus float result equals 12.0 by 5? Very similar, these 3 things. But it's shocking how many 115 students can't answer that. So pay attention to fundamentals. That's the point in terms of study skills again. Is that okay? Next. So that's about spaced repetition and testing effect. Almost everything that you do from primary school, middle school, high school to university, you're being tested on it, right? But in reality, a test is only as effective as the efficiency of its design. So sometimes we test people on things that don't really matter. So when you're studying something, you can study, but how do you assess that you actually got it? Through testing, through assessing. And the same happens in industry as well. You go through trainings, and then your work actually makes use of that training, right? In Comp115, the kind of tests or the major assessments you have are the module exams. The module exams assess your topical understanding, so each topic separately. But the main assessment for Comp115 is assignment, more comprehensive. So an assignment is where we see if you can put all the things together that we have taught you to come up with a better program. What I'm going to do is, this practice package that I have written with my students, I'm going to release on iLearn. Is that okay? I'm not a big advocate of releasing solutions. I think it's better to study without solutions, but that said, because this is something to help you understand things, I will also provide solutions. So after week 1, for example, you might want to draw this program, this code, this shape. And anyone can see that there's a background of black. One more thing, and I'm not kidding around. If you have difficulty recognizing colors, please let us know, okay? Because in these questions, obviously because these are written it's not mandatory for me to give you these practice packages. I do this because I like to write question banks and students benefit from them. But in your module exams, typically you'll get the description. Draw a red circle at certain location. We'll also tell you what the color code for red is in the lectures, so you'll have to remember the color code. So even if you can't distinguish between colors sufficiently, you should be able to do that question. In your assignments, we won't ask you a specific color code, okay? So we won't say that this is the exact shade. For example, we will never say that draw something which has this exact shade. Plus minus 10 is fine. So don't spend a lot of time perfecting the color. Anyways, coming back to the point, we'll give you this piece of code. And in this case, you can change the size of the screen so it becomes bigger. So instead of 100 by 100, it's 400 by 400. You can also change the background to 0. 0 refers to black. I can then draw a circle at, let's say, width by 3, height by 3, off size, width by 3, height by 3. Let's see what it spits out. Fair enough. But if you want it to be a bit bigger, you can say, instead of width by 3 being the width of the ellipse, it's 40%. So it's slightly bigger. Or you can say width by 2, height by 2. I can change its color to this using fill. Now, colors are represented in red, green, blue. Or, if you provide a single value, it means red, green, and blue are all 0. So 0, 0, 0 is black. 255 is the highest value, and why is it 255 we'll talk about later. So now that I've drawn the red circle, I can also draw the green circle. As computer programmers, we are inherently lazy, and we like to copy and paste the code. But making the correct changes when you copy and paste is a skill that will be acquired slowly. I'm changing the center location to this. You can see, compared to the output required, the output that I get, if I compare them, there's one slight difference apart from the blue circle, of course, which is size are different. It's different. Well, because this is different. So if I problem solved. What's the difference between the red and green circles? There's a little border here, right? So again, before you do anything, you can say no stroke, and it erases the border. And then the blue circle, so after that there's a blue circle which is 0, 0, 255. It's in the middle of the screen in terms of X location, and it's a bit further down, its size is the same, and you get that. So you can compare them, and yes, I'm fairly happy with that. Sometimes you can make minor mistakes, and that's the output required, this is the output that you get, and the order of shapes is incorrect in this case, right? So it always pays to compare your output with the required output. Of course, if you have any trouble, then you can refer to the solution as well, but I strongly advise you to refer to the solution as the last desperate measure. If everything else fails, only then refer to the solutions. Okay? So that's about testing. So my point was, to begin with, there was a point to all of this, which was testing effect. Don't rely on module exams and assignments. Those are the assessments that determine whether you should move to the next unit or not. But in order to perform well in those assessments, these practice programs are the real assessment. This is what you have to do in your own time to get better at programming, to get better at 115, so you can then demonstrate that in the real exam. Is that okay? Of course, it will take time. You'll have to cut down on partying and stuff like that, but manage things reasonably. Any question about spaced repetition or testing effect? Yes? I'll talk about that in a little while. Yep. So your question brings us to the next topic in the lecture, which is transition to processing. The language that we are using is processing. Processing is a language that is itself written in another programming language, which is Java. Any code that you write in processing effectively becomes a Java program. But the good thing from your perspective is that when you write a program, I'm just going to write a very simple program. Is that okay? All I'm going to do is I'm going to draw a line from 2080 to 6080. Can you tell me can you describe in one word the kind of line that I'll get? Vertical, horizontal. So I got one vertical, one horizontal. So we can see, so this is purely through experimentation. I wrote some program that 0, 0 width height, and you sort of figured out that through that 20-40, that it's moving 20 to the right, 40 bottom. So gathering information through experiments is a key skill. So here, its x location is 20, y location is 80. Is it in the top half or the bottom half? Bottom half, because in the previous experiment, which is okay if you don't remember, but we established that the point 0, 0 is at the top and width height is at the bottom, where height is 100. So 80 is closer to 100, and therefore it's towards the bottom. So my first point, if I consider this window as my display window, will be somewhere over here. And then I've got the second point at 60, 80. So it's 60 to the right, 80 to the bottom. So because both points 2080 and 6080 have the same y value, it means they're hanging the same distance from the top, and therefore it's a horizontal line. So when I run this, I get a horizontal line. Some things I can do to make it a bit more clear. Background 255, and I run this, so it's a thicker line. Now, if I change this to 1080 and 9080, I get a line. In addition to being horizontal, is there any other word, is there any other keyword that describes this line? It's straight, very good, yep. It's a horizontal straight line. Anything else? Who said that? Very good. Equidistant. Can you elaborate on that term? That's right. It's 10 from the left, it's 10 from the right. So it is symmetric across the y-axis. So if you consider this as a page, and let's increase the size to 400, 500, 500. Of course, I'll have to change this to 490 now. And instead of 10, let's have it 70, which means 490 will become 430. So this line is 70 pixels from the left and 70 pixels from the right. Okay, so it's a symmetric line. If we consider this as a page and we fold it across the middle using a vertical fold, then it is symmetric. Okay? Similarly, let me change this to 70, 70, 430, 70. Draw a line 70, 430, 430, 430. It draws a line at the bottom. I can then draw a line from 70, 70 to 70, 430. And similarly on the other side as well. Yeah. Understanding symmetry is very useful. The reason being, let's say let's say in a module exam, we give you this image, and we ask you to write a program based on the specifications that the size should be 500 by 500. The top left point is at 70, 70. That's all you need. Because when you inspect the image, you can see that the image is symmetric across the x-axis and the y-axis, which means if the starting point is 70, 70, the ending point must be 500 minus 70, 70 to draw the top line. Is that okay? So a lot of it is through experimentation and learning from experimentation. And symmetry is one of the critical things. So, what's your name? Deep. Deep Seth. Is it the first name or first name, last name?
First name, last name.
Okay, Deep is your first name. Okay, Deep. For Deep's benefit, what did we learn? So what we learned is, I can define the size of a screen or the output using how wide do I want it and how high do I want it, which is also typically called width and height. So if I say size 200, 300, what you should visualize is that it's taller, it's higher, then it's wider. Okay? So its width is 200, but height is 300. Similarly, if I say 600 by 400, then it's 600 pixels in width and 400 pixels in height. In your mind, it should also generate a lot of other information as well, that the center point of this display window will be at 300 pixels to the right and 200 pixels to the bottom. We also learned that the top left corner is always at 0, 0. Now tell me one thing. If the top left point is at 0, 0, where's the bottom right point for a 600 by 400 display window? But when we say 600, 400, when we define the size as 600, 400, we are saying that it is 600 pixels wide. But if the address of the first pixel is 0, then the last pixel's address would be? That's right. It's actually 599, 399. But we don't care about it too much. The reason being that for all large display windows, it's barely noticeable whether it's width minus 1, height minus 1, or width height. So the correct information is width minus 1, height minus 1. One more thing. As soon as you define the size, built-in variables, width becomes 600 and height becomes 400. So you can use those variables later on. Let me demonstrate that again. This is processing. I'm going to click on this little butterfly sort of icon over there. It stands for the debugger. So the debugger lets you trace variables in the program. And once I enter the debugger, I'm going to click on the line number where I want to stop. A processing program can be stopped wherever you want using the debugger. Okay? And I'm going to place it here, 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 everywhere. Now, I press play, and it doesn't say run, but it says debug, which means that the entire program is not going to run. It's only going to run till the breakpoint, which is the pit stop. Everyone has seen Formula One races, right? So the cars take a pit stop. So what we're doing is we're adding a pit stop where the program should stop. We run this, and it's stopped here. Obviously, nothing has happened so far, because it's the first statement. So I continue, not debug again, because debug again will restart the process. So I continue, and you can see it's moved here. You can see that a new thing has come up in the debugger trace, which is processing width, height. So the built-in variables, width and height, each become 500. I can always change these values to 300. Restart the execution, resume, and now width is 300, height is 500. So just experimenting with processing not for a long time during the day, only for like half an hour, 1 hour, is enough for you to learn a lot of stuff. And if I resume again, it goes to the last line, and when I run that statement, a line is displayed here. You can see that the line has now gone out of the screen. So if I want to maintain symmetry, instead of using 500 as a fixed value, what should I use? Width. So we use width. Now it doesn't matter. So I can exit the debugging mode by clicking on that little insect again. Now when I click the play button, it runs. So you can see it's symmetric. I can change the size to 800, 200. It's still symmetric. And that's called a scalable program. It's a program where changes can be made, but the basic requirements are still satisfied. I'm going to go back a step now and one more thing. Instead of having to go through every link on iLearn to access the lecture material, this is the only URL you need to remember: software-technology.herokuapp.com. So all Comp115 lecture material is available on that website. And the hyperlinks are on iLearn. Right. So now we can get into the details of processing. So what I've said so far is the language we're going to use is processing. It's incredibly easy to download and install. Download the exe or the DMG, the package file, whatever it is, from processing.org. So the website is processing.org. So download the processing application from org, unzip it, and it's good to go. It's as simple as that. You can also carry it around on a thumb drive. So that means that you can go to anybody's computer and run processing programs there. So it's very easy. A processing program typically looks like you can run it or you can stop it. If you run an empty program, the output that you get looks like this. It's got gray. It's got gray outlines here, and in the middle is white, because this whole thing is actually a Java applet. The inner part of this applet, which is the white part, is what we call the display window. So the display window by default is 100 by 100, which means that it's 100 pixels across and 100 pixels from top to bottom. Is that okay? The entire applet is 150 by 150 pixels. These are very minor points. You don't really need to remember these, but for the sake of completeness, I like to talk about these. You can change the default size, or you can change the size of a processing app by specifying the size command. And you can say, I want the size to be 600 pixels wide and 400 pixels high. So this is how wide you want it to be, and 400 is how high you want your display window to be. And this will display a window which looks a bit like that. Yeah? As soon as you define the size command, these values, 600, it gets copied into a variable called width, and width becomes 600. So the advantage is that you don't need to remember 600 again. You can just use this value in your program, and wherever you say width, it will be replaced by the value that it holds. And that's your introduction to variables. That's called a variable. Variable is a value in the memory that holds some value. Sorry, variable is a label in the memory which holds a value. Similarly, the value 600, this is my OCD, by the way. I don't like to cross over, so I'm going around. The value 400 gets copied into height variable, which becomes 400. Then, if I say, draw a line from 3050, let's go back and assume that the display window is of size 100 by 100. Let's say I never change the size, so this is a new topic. If I draw a line 3080, 3050 to 8020, so let's start from here, and this is my initial 1, 2, 3, 4, 5, 6, 7, 8, I lost count. Okay, let's try this one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Success. And similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my 100 by 100 display window, where every block represents 10 pixels. We're going to get, this is the starting point. This is your starting point, or you can call it point 1, because actually, technically speaking, a line segment doesn't have a starting point, ending point. It's just 2 points. And this is your point 2. Within each one of them, each point is of the form x comma y. X represents horizontal displacement, Y represents vertical displacement, where the top left point is 0, 0, and the bottom right point, as we said, is width minus 1, height minus 1, but this, for the sake of sanity, we'll just call it width, height, which is actually, in this case, 100, 100. So where's the point 30, 50? It's 30 pixels to the right and 1, 2, 3, 4, 5, 50 pixels to the bottom. And that gives us point 30, 50. The second point, 80, 20, is 80 pixels across. Now that's where symmetry comes into picture, as I said. Going 80 pixels across is harder than going 20 pixels from the right. So if you have a good understanding that it's 100 pixels, then rather than going 80 pixels from left, you can just go 20 pixels from the right. Yeah? But this sort of thinking will need some practice. Also, don't get too bogged down by visual programming, because when you move from 115 to 125, it will become numerical programming completely. So here, I'm going 80 pixels across and only 20 pixels to the bottom. And that gives you the second point, which is 80, 20, and then you draw a line between them. So that's the output that you'll get. Is that okay? Now once you learn that skill, then you can basically determine the output of any given line program. Sometimes, when you draw a line, let's draw a line 60, 50, and 60, 50, and 290. Now, there are two things that can happen. What, you can see clearly the reason I'm saying two things can happen is because of this value 200. Because the entire display window is only 100 pixels high, when you give the Y value 200, two things can happen. Either processing can complain that this value is outside the window and not executed, or it can just determine that point and draw a line displaying only the visible part. It's the second option that processing takes. It doesn't stop executing, it executes, but only the visible part is shown on the screen. So let's take a look at that. So you go 60 pixels across and 50 pixels to the bottom, and that's point 60, 50. Point 290, sorry, 200 is the X value, is 100 pixels and then another 100 pixels. And 90 pixels to the bottom, which is over here. And it draws a point, it draws a line between these 2 points. So this part of the line is visible, while this part of the line is not visible. That's it. That's what happens. Which means that it's okay for coordinates to be outside the display window. It will still execute. Any questions here? Now if I ask you, let's take this, change this to bigger, maybe. Okay, so let's go here, and let's say this is my first point and this is my second point. I can draw really nice straight lines. And that's the next one. If each block represents 10 bytes, sorry, not 10 bytes, 10 pixels. If each block represents 10 pixels, what's the size of my screen? "90 pixels wide and 90 pixels high." So it's 90 by 90. Okay? Actually, processing doesn't allow you to have a display window less than 100 by 100. So if you do 90 by 90, it still comes out to be 100 by 100. Let me double check that. I'm not 100% sure. But anyways, that said, I want to draw a line from this point over here to this point over here. So what are the coordinates? 30, 20, and 50, 80. That's right, because the entire height is 90, which means 10 blocks from the bottom must be 80. So the statement would be, draw a line from 30, 20 to 50, 80. Which one is better? Draw a line from 30, 20 to 50, 80, or draw a line from 50, 80 to 30, 20? Doesn't make any difference. The point that I'm trying to make is that there are multiple ways of doing the same thing. For you, something might make more sense than the other person. Okay? So, yeah, both of these are exactly the same. So we call these two statements equivalent statements. So from the point of view of programming, those two statements are exactly the same. So those plagiarism softwares that the university may or may not have, what they do is they will translate both these statements to one statement. So even if you make these changes, those tools are clever enough to catch them. Next, let's say again each block is 10 pixels. If I have, let's say each block is 50 pixels. Each block is 50 pixels. What's the size of my screen? Or let me write it this way. What statement will achieve this display window? Let's see. 1, 2, 3, 4, 5, 6, 7. So 350 and 3, 6, 9. 450. And that's it. So that's what gets me the line. Now, I have a line that I want a horizontal line. So please think about the terms that I have. I want a horizontal line. One of the points on the line, I also want it to be symmetric across the y-axis. So when you fold the paper on the y-axis, it should be symmetric. One of the points is here, which is 50 to the right, and 1, 2, 3, 4, 200 to the bottom. Which means my line goes from 50, 200 to what? The keyword is it's symmetric and horizontal. 300 and